Hello there, I'm playing with junk again, and this time it's not junk, it's brand new. I made myself a Raspberry Pi portable computer with the Raspberry Pi 3 board here and the original Raspberry Pi 7-inch touch display. I added two lithium-ion batteries, a simple Chinese battery monitoring and charging device, and a small step-up converter. All the parts here can be bought from Alibaba or Banggood or whatever your favorite Chinese supplier is. And the wooden case is something I made myself because I like playing with wood sometimes, and it's really practical, it's easy to work with, and you don't need expensive tools to work with wood. Okay, let's turn it on. I also made a little stand, so I can set it here like that. Now, the reason for this video today is this Raspberry Pi has now a touch screen, but the graphical interface is not really made for touch interface. So I know there are different graphical surfaces here. You could download other GUIs and stuff, but I thought this is okay and it does what I need, and I mostly need the VLC player here, which I installed a couple of days ago, and it works pretty well. The only issue I have is I'm missing the right mouse click, so if I want to select some sub-menus or something, I only have my finger. I can tap on it, but that's it. But there is no way to get the right mouse button here. I know there are also additional software apps and stuff I could add, I could configure, but in fact I have a hardware solution for that. So that's just a small demo video here. I want to use this portable Raspberry device for recording videos from my thermal camera, from my FLIR camera. And so that's something I can take with me, start the VLC player, record to a file. That's easy, because I don't have a laptop that is fast enough. I only have a couple of old machines, and well, this is smaller, this is lighter, and it is at the end cheaper. Some of you may think, well, why not just take a mouse with you, like the small one here. This is specially made for portable devices, for laptops and other small computers. It fits into any computer pocket. But well, I only need the right button, so I thought, why not take all the electronic stuff that is inside the mouse, only with the right button and the USB interface, and put it into that case. And well, that's more. So first you have to open the mouse. There is a screw. It was hidden underneath this slider pad here. You take it away, you open the box, and then you see the PCB, which you can see here. And as you can see, there is only one big chip in the center. This is the optical sensor. It works like a small camera that detects in which direction the you're moving the mouse, so it detects up, down, left and right, and sends this signal to your PC so that the mouse pointer can be moved accordingly. The good thing is all the electronics, all the USB interface, everything is in this one chip. And there are many parts we don't need, so we need 1, 2 or 3 buttons. That's up to how you want to have it. So I only need 1 button, but maybe I keep 3 of them. I don't need the scroll wheel. I don't need the sensor for the scroll wheel. I don't need the red LED that lights up and that illuminates the table for my mouse. And I thought I could make it a little bit smaller. So what I came up at the end is this. That's my new 3-button mouse interface. As you can see, I made 2 separate boards to make it a little bit easier to put it into the Raspberry case. I have 3 buttons, I have 3 resistors, only 2 wires, and there's all the rest. That's the chip with the camera facing down, so the camera is now seeing this piece of PCB and nothing else. We have the 2 resistors from the USB data in and output. And well, I hooked up the switches according to the schematic. And well, I think I will show you the schematics. That makes everything a little bit easier to understand. I hope you can see everything on your screens. Here we have the USB interface, the cable that goes out. We have ground, data plus, data minus. I made a mistake here, that's a big minus here. And we have plus 5 volts. I have, so that's the schematic how it was originally inside the mouse. There was a capacitor, I left that away because I'm only using short cables and I'm putting it directly into the box. I don't need this capacitor. There is the red LED that lights up when you lift your mouse. If it's an optical mouse, you can see the red light. That's this LED. It is connected to the 5-volt rail with I measured 59 ohms. I don't know exactly what it was, but I don't need that LED and the resistor anyway. And that goes down to this pin directly. So this pin is to switch this LED on or off. So we don't need that pin anymore. Then we have here the scroll wheel. This is a 2-phase encoder that is connected to the supply voltage here. The supply voltage comes from oh, I just see that I made some mistake. Where is my mistake? Okay, yeah, I made that wrong. So there is another connection because that resistor is going directly to the 5-volt rail here. So this pin is driving only the LED and nothing else. There is no connection. Well, the scroll wheel. Okay, scroll wheel is connected to the supply of the chip. The supply of the chip comes from the 5-volt here, and goes via this 15 ohm resistor. I think this is made to reduce some noise, because there is an additional filter cap directly next to the chip with a 100 nanofarad capacitor to filter out the high frequency stuff. So here we have voltage DD, goes into the scroll wheel and comes back as a two-phase signal. And when you turn the scroll wheel, you will generate a rectangular signal here and a 90-degree shifted signal on the A line, or a signal on the A line and the shifted signal on the B line. So in fact it will look like that. Rectangular signals, 90-degree shifted means it's going like that. Always in the center of the signal, the other signal changes. And that way you can determine which way the wheel is turning. Because if you turn it to one side, A, B, for example, this B, A goes down before B goes down. And if you turn the wheel the other side around, this phase shift will be inverted and B will be ahead of A. So the only thing this chip has to determine is which one of the signal is ahead of the other, and then it knows which way the wheel is turning. But we don't need that and that, because I don't want the scroll wheel on my Raspberry device. So there's a lot. The scroll wheel can be removed. I need that resistor. Maybe I don't need it, but I leave it in. I will also keep the capacitors here. Then on this side we have ground on this pin. So there is a mark. I think that maybe pin 1, 2, 3, 4, 5, 6, 7, 8. Maybe the numbering is different because it's a different style of chip package. We certainly need the ground here. We will certainly need the data positive and negative here for the USB. USB data is going through this filtering stage here. We have two capacitors that reduce some high frequency noise, especially if you have a long cable. Maybe it's not necessary in my application, but I will keep them. And the 33 ohm here, I think that's only to prevent short circuits, or maybe it's also filtering a little bit, and it's also a little bit protection against ESD shocks and whatever. They always make this 33 ohm resistors in series, so I will keep them too. And well, that's everything we need. It's a complete mouse interface. I almost forget to mention the switches. That's the reason why I do all this tear down here and rebuild. We have only one pin that is connected to 3 resistors and all the 3 switches. So that's the mouse buttons, right, middle and left. They have different values of resistors. So we have 30K for the left, 30K for the left mouse button. We have 15K for the right mouse button, which is exactly half of that. And then we have 6.8K for the center or the middle mouse button. That's half of that, or a quarter of this. So if you push one of these buttons, the chip here will see 15K, 30K or 6.8K, depending on which button you push, you press, and then it knows which button you pressed. And if you press two buttons, that's interesting here with these values. For example, if you press the left and the right mouse button simultaneously, so 30K and 50K will go in parallel. So everything is referenced to ground here. 30K and 15K in parallel makes 10K. I calculated that before, I don't know this just like so. 10K is a value that is far away from 6.8K, and it's also far enough away from 15K. So it depends what this chip is doing. Maybe it recognizes that two buttons are pressed, or it simply says, well, 10K is a value, I don't know what it is, so I do just nothing. That's possible. Okay, that's the circuit. Let's have a look again what I did. That's the two USB inputs. You have to be careful not to interchange them. So if you change the positive and negative data line, your device will probably not work, or maybe it works half and half not. So the good thing is here on the PCB, oops, here it is, that's the original mouse PCB. Everything is written down on the PCB. Here is the connector where the USB cable was, and here we have USB plus, USB minus. You just follow the tracks. There are the locations of the two resistors going down to the chip. These two pins here, you know which one is positive and negative. Then I wrote down the colors of the wires in the cable. Here in this cable, green was the positive data, white was the negative data, and then black and red for ground and 5 volt, and another one for shield. I just cut that away because I don't need it. There are manufacturers, especially the cheap ones in China, they don't really care about the colors here. I had cables where red and black were inverted. So black was positive, red was negative. That doesn't matter as long as the connector here is connected in the same way. So if here negative goes to the red wire and the red wire goes to negative on your board, so no problem. But when you open the wire, when you remove the insulation and you think, oh, there's a red wire, must be positive. Well, don't be that sure. You better take your multimeter, you check it if it's really the right polarity. There are manufacturers that don't care and they make it wrong. Their stuff is working, but when you start taking it apart, so that's definitively a trap. Now let's see how it works. Well, with the switch outside here, it doesn't make much sense. I will of course mount this stuff inside the box with some bigger switches, but this is only for see if it works, a proof of concept if you want. So I can move the mouse pointer here with my finger, and I can push the right button to open the menu here. select one thing again with my finger, create a new folder, for example. Now I have the problem, I don't have a keyboard, so I just make a new folder with the name new, okay, and I have a new folder here, which is named new. Okay, I can also hit the right mouse button to move it to the wastebasket. Yes, please. And of course I can select the wastebasket and empty it like so. And that's functions I couldn't do only with my finger, so even if I stay longer here, the menu doesn't appear. I cannot empty the wastebasket, for example. Sometimes I have problems to start something with a double click here. It's a little bit tricky, you have to be very quick. But I can also move the pointer here and use the left mouse button to start my program. So I think I will keep all three mouse buttons just in case, because I have it and I can do it and it's fun. So I think I will mount them here on the top somewhere, or maybe in the center, somewhere where it's not in the way. Okay. Shut down. Thanks for watching.